Well, hello everyone, and welcome to this second edition of the Kubernetes Tools webinar series. This webinar covers KOps, and I've put together a very short presentation and a demo to give you a feel for what KOps is. So let's just take a quick run through of the agenda for this webinar. So the goal for this webinar is to introduce you to KOps, and KOps is a tool for Kubernetes cluster orchestration. And I'll do that by a short presentation and mostly a demo. Also prepared about 15 minutes for Q&A, so please put your questions into the chat, and I will answer as many as I can at the end of the session. And if I don't get to your particular question, we'll have a full write-up of the questions on the Cloud Academy community forum and also a follow-up blog post for this webinar for more information and more context around what KOps is for those of you who prefer text as well. So a little bit about me. My name is Adam Hawkins. I run the Site Reliability Engineering team at SaltSite, where we have roughly 350 containers in production. I've also created the Introduction to Docker and Introduction to Kubernetes courses for Cloud Academy. So feel free to check out those courses. They're available on a free trial if you're interested in learning more about containers and Kubernetes. And lastly, you can find me on Twitter, and I blog about this stuff quite a lot. So that's enough about me. I have prepared a short poll to learn more about you, to craft the remaining time we have together to best suit you. So if you can fill in the poll, that would be great. Okay, so I can see from the poll that the majority of you are not working with Kubernetes right now, and some of you are. So what I will do is spend probably more time giving some more background around what KOps is, and hopefully you can get a feel for this in the demo. I can see that also some of you are actually already using KOps, so I hope that you can take something away from this webinar as well. And for the 15% of you who are doing a manual setup, then I hope that you can take a KOps away from this session and no longer spend your time doing manual toil if you're dealing with Kubernetes clusters. So let's move on to the short presentation. So this is the short presentation. We have one slide with the agenda. So what I'm going to do is walk through creating different cluster topologies, how to get SSH access to clusters, and the different things you can do with KOps around modifying cluster configuration. This is things like adding more nodes, changing the number of masters, things like that. So since the majority of you are not working with Kubernetes right now, can just touch on a little bit around what Kubernetes is and how KOps fits into this picture. So Kubernetes is a container orchestration tool. It's a distributed system. It's developed by Google and now many open source contributors. And so being a distributed system, it's a bit difficult to set up. So if you've dealt with something like like a MongoDB where you have a primary, you have replicas, even other like RDMS type systems where you have the same sort of thing, you have the same type of setup in Kubernetes. So you have your master nodes where your Kubernetes API containers run, and your worker nodes where your containers actually run. And setting all of this up is certainly a non-trivial exercise. So there is a lot of legwork to go through to make this happen. The whole process is actually documented in Kelsey Hightower's Kubernetes the Hard Way, and it is in fact the hard way. So tools like KOps automate that process for different cloud providers. So what KOps is a tool to automate the operation side of working with Kubernetes. So KOps can create clusters with different topologies. So what I mean by topology is this might be machines running in a public network or a private network, maybe public DNS or private DNS or variations of the two, and other aspects of the cluster topology itself. So KOps can also do things like multi-master for your high availability requirements if you want to. It also has beta support for federated clusters, which is kind of, if you think of it as a sort of like failover for clusters at a cluster level. So you could have one cluster running in, say, AWS and another cluster running in GCP, and the containers can move to one cluster if it fails over. So that's what federated clusters is. It also gives you control over like things like AWS, like tags, labels, all the kind of various networking things, SSH access, and most importantly, sort of automates the grunt work around, say, scaling your cluster or updating the Kubernetes version or handling the things that kind of generally fall into what we call the cluster ops bucket. So what I will do now is I'm going to switch over to my terminal and work through some of these commands with you all and talk about them, sort of what KOps is doing under the hood while I go along. Now, unfortunately, I will be creating real clusters in this demo, and that will take some time, a couple, maybe 5 minutes between each cluster. So during that time, I will fill in the gaps and sort of narrate as I go along. So let me just come out of the presentation and pull up my terminal. So I hopefully have zoomed in enough. So if you can just comment in the chat if I should zoom in some more or not, that would be great. All right. So let me just check my directory. So I have KOps installed right now. So KOps supports creating clusters on AWS and Google Cloud Platform. And the way this works is KOps stores sort of the configuration in either what they call an S3 bucket, or I forgot the equivalent term on Google Cloud Platform. So that's where it keeps its state. And you can create these clusters. So the only real configuration you have to do is export an environment variable. So if I look, you can see here that I have export this KOps state store environment variable. And that's where it's going to write all the information about these clusters to. Now, for those of you who are already working with Kubernetes, the overall feel for working with KOps will feel very similar. So if you know the CubeCTL commands like CubeCTL, create, and then -f some file.yaml, the same thing applies for KOps. So what I will do now is create a cluster. Now, what you should hopefully take away from this is how easy it is to get going with creating clusters. This is an activity that might take you hours or maybe even days to do by hand, which can now be accomplished in a matter of 10 or so minutes. So the way this works is we say KOps create cluster. Now this feels exactly like it would for CubeCTL, and that's also by design. So now I can say --yes. Now I'm doing this here just explicitly to avoid the confirmation prompt. So now I have to give it the zones. This is would be the GCP zones or the AWS zones where I actually want to launch this infrastructure. So what I will do is create a 3 availability zone cluster in EU West 1A, EU West 1B, and EU West 1C. Now, the next step to do is fill in the cluster name. So I will call it demo./deploy.com. Unknown flag zone. My mistake. So here, let me fix this. It's supposed to be a zones plural. Now, Kops is quite an interesting tool because it actually has, at the time of this webinar, actually 3 different ways to interact with the various cloud providers. So what you see Kops doing right now is using its own internal code to create all of the different infrastructure on AWS. Now, Kops can actually export Terraform if that's your thing, and I believe the maintainers are actually working on using CloudFormation for AWS. So if you are interested in those kind of things, you have a few different options for how to actually communicate, how to work with the sort of the outcome that Kops wants to create. So just from that one command, it has now created all of the Kubernetes infrastructure required to have a working cluster. Now, as we see here, it says the cluster is starting. It should be ready in a few minutes. So if I come back over to my AWS console, let's just zoom in a little bit here for you. So you can see here, let me refresh so we get updated information. So Kops has created multiple autoscaling groups for the masters. It's also created an autoscaling group for the nodes, and done all of the networking, and in the case of AWS, all of the Route 53 things to create the DNS and this stuff as well. Now, as it says, it may take a few minutes for this to happen. So Kops includes a command called validate. I can type the name of the cluster. And what this will do is, oh, my bad. Validate cluster. I always make that mistake. Now, there's a sort of unfortunate UX fail in this command, at least on version 1.5, that if you run this command right after you create a cluster, you may not get any useful information because the command is trying to connect to the API for the Kubernetes cluster. And as all the machines are coming up, you may or may not get a response. So what I like to do is just repeat this command over and over again until it succeeds. Now, this is what I was saying. It says cannot get nodes for this cluster from this API. So if you take a note of this domain name, that's the name of our cluster. Kops has automatically created a load balancer for all of the master nodes where the API service containers runs, and set that CNAME up with the API.cluster name. So now if I run this again, let's see what happens. So this is a very kind of simple flow, and once we get the cluster up, we can get the kubeconfig. So we have created this cluster, but we need to actually configure CubeCTL to talk back to this cluster. So once this thing completes, we can get a feel for that, and then move on to some more complex cluster creation examples. So depending on the type of instances you use, this process may take, longer. So by default, if we come back over to the console, we look at the instances. I believe it's using like M3 large. Yeah, so let's say instance state. Let's look for running. So you can see here that we have the masters are still initializing. It's using M3 medium by default and T2 medium for the nodes. And of course, you can configure these things. There are all sorts of extra configuration flags. Just give you a quick overview. We'll see some of these as we move forward. Just zoom out so we can fit more on the screen. So you have say if you want your machines to have public IPs, you can restrict SSH access to given IPs. You can do that. See, GCE, AWS, DNS, as we'll see. You can set different Kubernetes versions. You can configure the number of masters you want. You can configure the different instance types for the masters, what sort of regions or zones the master should run in, all sorts of different, all sorts of different things. So let's try to validate the cluster again. Hopefully you can see what this looks like when it works. Okay, so now we actually have a cluster that is booted but not necessarily entirely ready. So you see that it says validation failed, and you can see the role for this particular node is not ready. So at this point in time, we may want to run this one again just to see. Okay, almost there. So in practice, if you're doing some sort of automated setup, maybe you have a script. Oh, look at that. Okay, your cluster is ready. So in practice, if you are having a script to say automate the creation of your clusters, where you say do kops, create cluster, then probably you'll want to loop and run this command until it succeeds within some kind of particular timeout. So now I have a functioning cluster. So I can run, say, anything against this. So then it will automatically create the CubeCTL configuration and just use the name of the cluster. So the cluster is up. And also, if I wanted to export, I could. So you can see all of these things. So you kind of get the idea. So at this point, Kops now has created a fully functioning Kubernetes cluster with HA, all of the setup for the etcd, all of the internals, all those things are already set up in about, 10 minutes or so. Not bad. So if you want, you can also interact with these things. So as I mentioned before, Kops sort of mirrors the way CubeCTL works, or Kubernetes works in general. So it actually has a defined, what they call maybe a cluster spec. This is like a YAML file in the same way that you have your pod.yaml or your deployment.yaml, those kind of things. So if I say CubeCTL, oops, not CubeCTL, Kops, say get cluster, and then give it the name. So demo./deploy.com. So you can get all of the clusters. And you see here you get similar output, which you expect from working with CubeCTL. Now, if you want to get the whole thing, I believe we can just say .oyml. Right. So let me just pipe this to less. So and you get an idea that you can see, just like with the Kubernetes stuff, you have your API version, kind, cluster, spec, and then you have all of the different kind of configurations. So you can see that Kops has sort of filled in a lot of this for us, specifically things like the network CIDR, the CIDR of the different AWS availability zones, and the topology. So if we wanted to, we can also edit this cluster. So if we edit it, let's say that we want to add some more nodes. Like if we want to, say, have more than 2. Maybe our requirements change and we need more machines. So we can say Kops edit IG, which is short for instance group, and then we want to edit the nodes instance group for this particular cluster. Ah, right, my bad. So we want to edit the nodes instance group, and we have to say dash dash name. There we go. So we can see here the AMI that's in use, the instance type, these things. So if we want to just say scale up, it's easy to say min size 4, max size 6. Now we can save this file, and then Kops will give us the instructions for what to do next. So now we can say, we want to say Kops update. So what we've done now is just modify the config file, but we actually have to apply those changes. So we can say Kops update demo./deploy.com. I always forget the second thing. Now, what Kops will do is then look at what's been written in those files and then look at the diff of what needs to be done. Now, it will tell us what it will do. In this case, it's going to create some additional AWS IAM policies, and it's going to modify these two particular resources. And then it tells us the next thing that we need to do. So if we rerun this with --yes, it will go ahead and apply. Okay, so I was reading one of the questions in the chat. So let me, now if I validate this, now we'll see what is going on at this point. Then we should hopefully see that there are 4 nodes. Okay, it's not ready. Masters, node's not ready 04. I'm not sure if this one actually here is a bug because it says that validation failed, but everything looks to be in the ready state. But those machines now are still coming up. If we wanted to, we could check cross back to the AWS console, find the auto-scaling group, then look at the history for that particular, for the auto-scaling group. It's right here, activity history. Yeah, not yet in service. So things are happening. So while that's happening, I will do my best to answer this person's question, which is, can you explain how CubeCTL relates to Kops? So first of all, there is no real relation between CubeCTL and Kops. The only real similarity is that they follow a similar kind of user experience, like a type of design, so to say. So for CubeCTL, when you're working with the Kubernetes API, you would write something like CubeCTL create -f and then say your pod.yml. Now with Kops, you can also say CubeCTL, no, oopsie, sorry, Kops create -f cluster.yml. So they are related in that they both use or are part of the Kubernetes ecosystem. So Kops create the clusters required to interact with CubeCTL. And when you create a Kops cluster, it will automatically generate the CubeCTL configuration so you can run commands against that particular cluster. So is it accurate that the CubeCTL is cluster specific, whereas Kops builds the cluster specified design by CubeCTL? No, not specifically. Kops and CubeCTL are separate projects with separate, separate specs and things like that. The role is that Kops creates clusters that you can interact with CubeCTL. So hopefully I answered that question. So now that, let's just validate it one more time. I can type it correctly this time. Let's see what happens. Okay, not ready, but now we can see that there is, okay, more stuff happening. So for the sake of moving things along, I will just assume this thing is going to complete, and I'm actually going to just delete this cluster and give it the -- yes, so we don't have to wait. So I can show you the more complex things you can do with Kops topologies and different settings and things like that. Okay, while it's deleting, I'll pick up another question. Is there any alternative tool to Kops in open source? So I didn't mention it yet, but Kops is in fact open source. So I'm not sure if that was part of the question, but I think it's a fair thing to clarify. So there are other options in this space. There are a few. One is a set of tools by Apprenda, which is in their, I think they're called the Kubernetes Enterprise Toolkit. I don't remember the exact name. And CoreOS also provides Tectonic with a command called cube-AWS, but I'm not sure if that one is AW or is open source. But as far as open source offerings go, Kops is pretty much as official and well supported as you'll find in this space. So one other thing to highlight as a follow-up to that question is you may come across old references to something called CubeUp or CubeUp.sh, and that project is deprecated in favor of Kops. So if you are researching the area around cluster ops and automation, and you come across something, a blog post or old documentation talking about CubeUp, you can just pass on that, just ignore it. It's not worth getting into. All right, so now that it's deleted, you can also ask Kops to just get the clusters. So it'll give you a list of everything you have in your state store. So as we expect, no clusters found. So now I want to give you a flavor for the different kind of things that you can do, the different kind of clusters you can create with Kops. So just like before, I'll create a cluster and I'll put everything on another line. So you can also customize like the networking layer in the cluster itself. There's a few different options like Weave, Flannel, Calico, and the CNI. Truthfully, all of these different options, I don't know which ones are better or most suited for particular use cases, but I've been using Weave and have not had any problems. Now, in this case, I will create the cluster again in the 3 different regions. 1A, EU West 1B, and EU West 1C. Okay. Next thing, I can say topology. So this is an interesting setting that we talked about just briefly. But in this case, what I'm doing is I'm telling Kops that these machines should be created in a private network. So no public access to these machines. So now you can also give a -- bastion flag, which will create a dedicated machine for SSH access to the particular machines in this network. So just to clarify again what is happening, it is creating a VPC, that's a virtual private cloud in AWS with private subnets, and all of the machines will be placed in those subnets, and it will create a bastion instance that accepts traffic, SSH traffic from the public internet, and from the bastion you can jump into those machines. Now let me just give it a name and let it go. Now, while that is doing its thing, I will take one of the other questions. Is where do you configure AWS credentials in KOps to create instances? So that's a good question. So KOps is written in Go and uses the Go AWS SDK for communication back to AWS. And if you have ever used any other project that happens to use any of the other SDKs in any language, you know there's a pretty standard pattern for how you can configure applications that need to talk back to AWS. So this might be explicitly setting an environment variable, the AWS access key ID and the AWS secret access key environment variables, or setting something like the AWS profile environment variable. As far as I know, I don't think there's any exact way to say pass explicit credentials into KOps. It relies mostly on the environment variables or the existing like configuration files you have for the AWS CLI, and that's again built into the Go SDK. So in my case, I actually have an AWS profile in use right now. One thing to note here is that there is currently a open feature request / bug in the Go SDK / KOps. Truthfully, I'm not sure exactly where the problem lies, but if you have an AWS profile that uses MFA, that will not work with KOps out of the box. So you'll have to write your own wrapper around using MFA with KOps, and luckily that is documented as a workaround, and you can find a script in the documentation to do that if you have that requirement. And for those of you who are looking to adopt KOps, I highly recommend that you do use MFA around KOps, because you don't necessarily want a random command being executed that can potentially modify your production cluster. So again, you can find that in the documentation. All of the documentation is kept on GitHub, in the KOps repo, and in the docs folder. You'll see a bunch of markdown files, and you get the idea. Now let's see what's going on back with our cluster. So pre-creating the DNS records. And again, all of these things do take some time. So at this point, again, it has just initiated the creation of all of the infrastructure on AWS, and now we have to wait for all of those instances themselves to provision. So we can repeat that process with KOps validate, or polling with some type of CubeCTL command or something like that. So in the meantime, let me keep answering the questions. Let's see. All right, this is a good question. Question is it safe to update a Kubernetes cluster while pods and other things are in service? And like most things in engineering, the answer is it depends. So if you are going to, say, add nodes to a cluster, like non-master nodes, but worker nodes, yeah, you can do that. If you are going to, say, remove nodes, then you want to do some more work before that happens, like updating the scheduling rules to move containers over to a new node. And of course, it also depends on the type of update you want to be doing. Say, for example, changing the Kubernetes version. That one you probably want to be more careful with. I've not actually had a chance to test that one yet, but at this point in time, my approach is to test all of the different updates on a dedicated, like, staging cluster, just to see what happens. So again, the answer to that one is it depends on the type of change that you're doing. All right. Let's see, what other questions do we have? Yes, thank you for whoever asked this question. Can KOps reuse an already created VPC instead of creating a new one? And thank God the answer is yes. So this is a very common requirement for people who are looking to adopt Kubernetes. that they have existing infrastructure in AWS and they need to talk to it for security reasons and firewall reasons. When you create the cluster, I can highlight these options for you. Other way, so create cluster. You can pass in two variables or two options. First is your VPC, that's the first value, and then you also have to pass in, where is it? Some subnet flag. Yeah. Network CIDR. So if you have an existing VPC, odds are you should be able to use it with Kops. Just pass in those two flags. And I will add a follow-up to that question, is that some of the topologies may not work with existing AWS infrastructure. For example, if you want to use private DNS but have a public Route 53 hosted zone, that's not going to work. So suggest you just peek around at the different options if you are looking to deploy into an existing VPC or kind of into a brownfield type environment. All right, so now let me validate this cluster. Let's see where we're at with this one. Okay, your cluster is ready. So now I have my SSH key. Now I should be able to SSH into one of these Bastion machines. So I can say SSH admin at Bastion dot cluster name. So Kops has automatically created this Route 53 DNS entry for us for Bastion, which points to an ELB fronting our Bastion machines. So if I have my keys correctly, ta-da! So now if I wanted to, I can come back over to, or do I have this information here? Let's see. Okay. So if I pick one of my machines, let's pick just this master, just as an example. Now I have the private IP. Let's just copy that. But first, astute viewers will recognize the missing agent forwarding. I should actually add that. That's my GPG agent, for those of you who are unaware. And now let's check. Okay, cool. So now let's repeat this. And then we can SSH into one of the machines in the cluster itself. Now, if we wanted to, we could probably look at like Docker PS, and you can see all of the stuff that it's got going on. So that just gives you a flavor for the kind of things, the kind of infrastructure that Kops can automate for you. You see we have Weave running, we've got the Kube scheduler, we've got the API server, Kube proxy, etcd, all of the containers you need to actually run Kubernetes. So now let me just back out of all of that stuff. Now, let me come back to the questions. Okay. Can we use Kubernetes and Kops for Azure? The answer to that one is kind of. So I'll take that into two parts. So can we use Kubernetes on Azure? The answer is yes. And the Azure Container Service actually gives you a hosted Kubernetes. And if you want to, you can go through the manual setup to create a Kubernetes cluster using Azure's infrastructure as a service offering. But KOps at this point in time does not support Azure. Other question from the audience is, how does KOps work with federation? Now, that's a good question, and I'm going to tell you that this is not my exact area of expertise, and my current understanding is that this is in kind of beta-ish / alpha. So I've not attempted it yet, but the only thing that I can tell you is that they do have some existing support for federation, and that in time it should work. Kind of a hand-wavy type answer. All right, let's see, what other question do we have? So, can you migrate from a single master to a multi-master setup after the fact? That's a good question, and the answer is yes. And luckily, there is a guide on that one. What is it? Single to multi-master. So you have an example here of what to do: back up the main cluster, and then say create instance groups. So this is your master instance group, and then edit the cluster like we shown, and then after the manual work, actually, as I show here with CubeCTL, to add these masters. But yes, you can. Okay, next question. What does the day 2 problem of operation and troubleshooting look like with KOps? And that is a good question. So I will tell you my own experience with this, and it has basically been fine. The problem that I myself face is that depending on how much KOps supports of what lower level Kubernetes type things you configure, you may not have complete control over all of the exact details of the final Kubernetes installation. But as long as you can get into the machines themselves, in this case, as I showed with the Bastion topology, you can SSH and see what's happening. You should be able to get going. Personally, I'm also a bit hesitant on their inbuilt infrastructure automation. I am personally waiting for the CloudFormation just to handle those type of things. But if you need something that is accessible right now, you can consider using the Terraform output. But right now, sort of the best solution to kind of the day 2 problems is to actually join the KOps Slack channel on the Kubernetes Slack. The maintainers are very active and very helpful. Not even actually just the maintainers, but the community itself have been really receptive around all kinds of issues, feature requests, and things like that. So all in all, I think it's good, and you should be able to get what you need done. I'm a bit curious to see what will happen around some of the more complex upgrades, like upgrading Kubernetes versions or more complex types of cluster things. Like, for example, Kubernetes 1.6 came out and they used etcd3, and 1.5 used etcd2. So that kind of thing I'm skeptical about because it's hard enough to do a manual. I'm not sure what it looks like to automate that, but I think that we have the tools and access we need to do kind of the debugging and troubleshooting that comes up. Okay, next question. How about mounting volumes for containers running through KOps? Does it provide options? So I'm going to unpack that question a little bit and clarify exactly what KOps' role is here. So if I were to rephrase that question, it makes more sense to reword it as, how about mounting volumes for containers running through Kubernetes? Does it provide options? So again, KOps just creates Kubernetes clusters. So Kubernetes does support things like volumes for containers. You can find that out in the Kubernetes documentation. I have one question. Does KOps use Elastic Load Balancer or Kube Proxy? I'm not sure exactly what you're talking about, so if the person who asked that question can clarify it, I can give a better answer. Okay. Next question. Is there any documented way to migrate existing clusters to KOps managed clusters? There is something, although I'm not too sure exactly how it will work. I can show you two commands for that. There is, let's see, Kops Toolbox. Yeah. Yeah, so you have convert an imported cluster into a Kops cluster. So personally, I have not used this too much, but if you're curious about it, you can look into this command and perhaps into the documentation for importing. Not too sure. Okay. All right. Next question, just a few more before we wrap up here. Make sure I start from the beginning. So one question, is there any other task KOps can accommodate if modified apart from provisioning cluster? I don't think so, because KOps' entire scope is really focused around cluster ops and the work around managing cluster infrastructure themselves. So anything really beyond that is outside of KOps' scope. Okay, we have one other question. What's the difference between ECS containers and what's the difference between ECS and Kubernetes? So that is a big topic, but I will give you a short summary. ECS and Kubernetes are both container orchestration tools intended to solve similar types of problems. One big difference is that ECS is closed source and is actually a set of AWS APIs, where Kubernetes is a completely open source tool which can run on any infrastructure. And there are varying different types of things that you can and can't do with the containers inside each orchestration tool. One big difference between ECS and Kubernetes as well is that Kubernetes actually supports different container runtimes, like Rocket, for example. And at this point in time, I don't believe ECS can do that. So they're both container orchestration tools. ECS is AWS specific. Kubernetes is infrastructure agnostic. Another question, is there any documented mapping between CubeCTL constants to KOps constants? I'm not sure exactly what that what you mean. Sorry, I can't answer that question. Next question, why should one use KOps on GCP instead of GKE? Now, that is another good question, and that really depends on what kind of scope you want and what kind of responsibilities do you want to have in a team. So you just have to do the research to find out if that makes sense for you. And personally, from my perspective, I don't see a real upside from using KOps. If I was on GCP, I would prefer to use GKE over KOps. Now, the reason that might change this is that there are perhaps some sort of security rules or existing infrastructure type things that I wouldn't be able to use GKE, and KOps is certainly more flexible than GKE, but those are trade-offs that you have to consider. Okay, so of another question, I'll do my best to unpack this one. I think maybe I have failed in explaining the separation between KOps and CubeCTL. So the question is, so CubeCTL has predefined variables which you can override in order to migrate CubeCTL clusters to KOps. Is there any mapping between these variables? So So the premise behind the question is flawed because the clusters are not actually, the cluster infrastructure is not managed by CubeCTL. CubeCTL is a way to interact with the Kubernetes APIs, which run on the Kubernetes cluster. So KOps creates the infrastructure to run the Kubernetes cluster and gives you the APIs that you can point a Kubernetes client to, like kubectl. So I'm not really sure what kind of predefined variables you're talking about, what mentioned there, but I think first thing to understand is the separation of what kubectl is and what KOps is. So again, kubectl is a Kubernetes API client, and KOps is a tool to automate the creation of Kubernetes clusters. I hope I got something of what you were asking. Okay, so we just have a few minutes, so I think we can wrap up now if there's not one last question. All right. So let's come back to the presentation. So we went through the questions, and now we have the wrap-up. So thank you, everyone, for joining. I hope this was interesting and informative, and you learned something. If you take anything away from this session, it's that if you are looking at setting Kubernetes up manually, odds are you may not have to do that, so I recommend you check KOps to automate that process and further ease the ongoing operational work around managing the clusters. If you want to learn more about Docker or Kubernetes, you can check out my 2 courses on Cloud Academy, which are available on free trial as well. And you can also check out my past webinars on Kubernetes itself. There's a 2-part series, actually a 3-part series introducing Kubernetes. You can find that on cloudacademy.com/webinars. And I think that's about it. So again, thank you everyone for joining. I hope you enjoyed it, and I hope to see you all again soon. So good luck out there, and happy shipping.